Hi, welcome back to another video. Today we're going to be taking a look at some rates of reactions questions. The question reads, two experiments are carried out to investigate one of the factors that affects the reaction rate between magnesium and dilute HCl. The reaction that takes place is represented by the following balanced equation. So they give us a diagram that basically explains how this reaction is conducted. And they tell us that in experiment 1, a certain mass of magnesium ribbon, so they've written that in italics, so it must be important, reacts with excess dilute hydrochloric acid. In experiment 2, magnesium powder, so that's, again, it's in italics, so it must be important, of the same mass as the magnesium ribbon, reacts with the same volume of excess dilute HCl. The concentration of the acid is the same in both experiments. The apparatus alongside is used for the investigation. Question 12.2. For this investigation, write down the independent variable. So in any reaction, the independent variable, we know this, independent, is the variable that is changed. So it is a thing that is changed. So what are they changing in this experiment? They are changing the state of division of the magnesium. So to answer that question 12.2.1, it is the state of division. And what does state of division mean? Basically, it's the state that it's in. For example, the magnesium in the first experiment is in a ribbon form and the second one is in a powder form. So that's going to affect the surface area. So the word that, or the sentence that we use to explain that is state of division. Question 12.2.2, the controlled variable. So for controlled variables, there's not necessarily one thing. Controlled variables are what things in the experiment would then need to be the same. So since they said that they are investigating one of the factors that affects the rate, it means that if they change the state of division, the other factors need to be the same. And what are the other factors? So it could be the mass of magnesium, right? It could be the concentration of HCl. So those were the things that were mentioned to us. So let's just go with that. Okay. Next, we have a diagram. So the question reads, the change in mass of magnesium is calculated and recorded in 2-minute intervals for both experiments. The results obtained are shown in the graph alongside, not drawn to scale. Okay, so experiment 1, experiment 2. So let's remind ourselves, experiment 1 was done with the ribbon and experiment 2 was done with the powder. Okay. So question says, use the information on the graph to calculate the volume of hydrogen gas produced in experiment 1 from t equals 2 minutes to t equals 10 minutes. Take the molar gas volume as 25 dm cubed per mole. So in this region here, from t equals 2 minutes to t equals 10 minutes. Okay, now what we can do is, okay, so let's start with our formula. That makes the most sense. So they want the volume of hydrogen gas. So we got our formula. Our formula is going to be 12.3.1. So number of moles is equal to V divided by Vm. Now, since we want the volume of hydrogen gas, we need the number of moles of hydrogen gas. So we don't know the number of moles of hydrogen gas, so we need to calculate that. So we look at our graph. This gives us the mass of magnesium, right? Now what we can do is we can use the graph to calculate the number of moles of magnesium and then use a mole ratio to get the number of moles of hydrogen. So let's check this. So at 10 minutes, there was 0.2 grams of magnesium. And at 2 minutes, there was 2.6 grams of magnesium. So what we can do is we can calculate the mass of magnesium. that was used. So that's going to be 2,6 minus 0,2, and that's 2,4 grams. Now from here, we can get the number of moles of magnesium. So the number of moles of magnesium is equal to mass divided by molar mass. The mass is 2,4, the molar mass is 24. That gives us 0,1 moles. Now we can go to our mole ratio. And the mole ratio of magnesium to hydrogen is 1:1. So that means, so the number of moles of magnesium to the number of moles of H2 is 1:1. But we don't have 1 mole of magnesium, we have 0,1. That means we must have 0,1 moles of H2. Now that we know the number of moles of H2, we can use the formula that we wrote at the beginning to calculate the volume. So the number of moles, let's clear this. So number of moles is 0,1 equal to volume divided by 25. We can then solve for the volume. The volume is then going to be 2,5 dm cubed. Let's put a box around it, and we're done. So the basic steps that we followed again was we calculated the mass of magnesium, then number of moles, then mole ratio. And then lastly, we calculated the volume. All right, let's move on. Question 12.3.2 reads, calculate the initial mass of magnesium used if the average rate of formation of hydrogen gas in experiment 2 was 2,08 times 10 to the negative 4 moles per second. Now, this is a 5-mark question, so obviously more than one calculation needed. But let's go to our graph. So we want to look for the initial mass. So in other words, we want to look for what is this value here. We don't know what that is. What we know for sure is that it must be more than 2,6. That's what we know for sure. Okay, now let's focus on reaction 2 since that's what they are talking about. So let's highlight this. So for reaction 2, or experiment 2 rather, we know that it took 10 minutes. Right? So it took 10 minutes. We don't know any other information from the graph because the information that was given was for experiment 1. So we can start with that. So we know, so 12.3.2, we know the time is 10 minutes, right? And we know the rate. The rate is equal to 2,08 times 10 to the negative 4 moles per second. Now, since this is in seconds, in order to use the time, we need to convert the time to seconds. So 10 minutes, we convert this to seconds, so times 60, that's going to give me 600 seconds. Okay. Now, let's think about how we calculate rate. Rate is calculated, in this case, by the change in the number of moles divided by the change in time. Now, we know the rate, 2,04 times 10 to the negative 4. That's equal to the number of moles. And remember, this is the moles of H gas, hydrogen gas, divided by the time, which is 600. So that means the number of moles of hydrogen gas is going to equal 600 times that value. So 600 times that value is going to give me 0,125 moles of H2. So now we know the number of moles of H2 that was produced. Okay, we can use the mole ratio to then calculate the mass of magnesium that was reacted at the beginning. So we know the mole ratio already, the number of moles of magnesium to number of moles of hydrogen gas. We know it's 1 to 1. So if I have 0,125 moles of H2, it means I must have 0,125 moles of magnesium. Now that I know the moles of magnesium, I can then calculate the mass. So remember, number of moles equals mass divided by molar mass. 0,125 is equal to the mass divided by 24. And now if we cross multiply, we're going to get a mass that is 2,995 grams. And it's fine because remember, we expected a value that was greater than 2,6. So 2,995, I mean, you can basically round that to 3 grams. And that's fine. So again, not too difficult. Remember, step 1 was use the rate to calculate the number of moles. Step 2, use the mole ratio. And then step 3, calculate the mass. Okay, question 12.4. So 12.4 reads, use collision theory. Let's just get this right. Use collision theory to explain why the curve in experiment 2 is steeper than that of experiment 1. So experiment 2, remember, they use powder. Experiment 1, they use a ribbon. So what does that talk about? So we can say that 12.4, experiment 2 used powder, right? So powder has a greater surface area, right? That means more particles with correct orientation for a reaction. That means greater effective collisions per unit time. So this is important. And then that means a greater rate, which means steeper slope. Okay, and that's it. I hope you liked the video. I hope you found it useful. If you did, please consider leaving a like, sharing, subscribing, whatever. And if there's something specific you'd like me to do or a specific question you want to ask, let me know in the comment section below. And until the next one, bye-bye.